So in this video, I want to consider x squared plus 4, okay, and the properties that this expression has. Now, later on in the algebra section, we take a look at what quadratic curves look like, okay? So we would look at something like y equals x squared plus 4 as an equation. And if I draw on x and y axes, then this curve has the shape that looks like this. Oh, that wasn't particularly good. I was meant to be symmetric on the y-axis, but that'll do. Okay, so it has the y-axis as a line of symmetry. And this point, its lowest point that it reaches is 4. Okay? Now, the x-axis is the line y equals 0. Okay, so you can kind of think of this as 0. So you can say that the x squared plus 4 is always above that line. Okay, so we can say that because the shape, the actual parabola here that we have, is always above the x-axis, you can always say that that's actually greater than 0. Okay, for any value of x, any real value of x that you pop in, it will always be greater than 0. In actual fact, we can do one better, can't we? We could actually say, well, here's 1. It's always larger than 1 as well, isn't it? In actual fact, it's always larger than 2. Because it's always above that line. It's always above 3. Okay? It's always above 3.9. But when we get to 4, we can say that actually it's always greater than or equal to 4 for all real values of x. Okay, so there is one point where it is equal to 4. That's when x is 0. So you get 0 squared plus 4 is 4. But other than that, you'll always have a value that's greater than 4, even if you substitute a negative number in. So minus 1 squared plus 4 is 1 plus 4. So that's 5. Okay, and that's why when x is minus 1, we're getting a value that is above 4. Okay? Don't worry, my sketch isn't to scale. Okay, that's fine. So, what we can do is we can generalise this. And we can look instead at y equals x squared plus a. So this is a parabola with the y-axis as a line of symmetry, where its lowest point it sits on is a. So we can say that x squared plus a will always be greater than or equal to a for all real values of x. Okay? Now, to be clear, this isn't true if you've got x cubed plus a. X cubed has a different shape. If you want to investigate that, x cubed plus a, so y equals x cubed plus a, would actually look like this. Okay, so actually there is a point, this region, where it goes below a. So it is not correct to write down that, unless you say that x has to be greater than or equal to 0. Okay, so we can't say that in general. But for this quadratic, we have this property. So you're always able to say that x squared plus a is greater than or equal to a for all real values of x.